This is our lab 3 and it's about the electroscope. Before going to the electroscope, we need to explain some concepts, like charge by induction. Charging by induction is when a charged object is brought close to but does not touch the conductor. In the end, the conductor has charge of the opposite sign as the charge of the object. The next concept is charging by conduction. Charging by conduction involves the physical contact of a charged object to a neutral object. So when an uncharged conductor is brought in contact with a charged conductor, charge is shared between the two conductors, and so the uncharged conductor gets charged. During charging by conduction, both objects acquire the same type of charge, a difference from charging by induction, where the objects acquire different charge. Our third and last concept is ground or earth. Ground is a direct electrical connection to the earth, a connection to a particular point in an electrical or electronic circuit, or an indirect connection that operates as the result of capacitance between wireless equipment and the earth or a large mass of conductive material. Electrical grounding is important because it provides a reference voltage level called zero potential or ground potential, against which all the other voltages in a system are established and measured. Once explained these three concepts, it's time to go to the electroscope. But before going to our own electroscope, the one we made us, we need to know what is an electroscope and how does an electroscope work. An electroscope is an instrument for detecting the presence of an electric charge or ionizing radiation, usually consisting of a pair of thin gold leaves suspended from an electrical conductor that leads to the outside of an isolating container. An electric charge brought near the conductor or in contact with it causes the leaves to stand apart at the angle because, according to Coulomb's law, the like electric charge either induced in or transferred to each leaf causes them to repel each other. An electroscope is made of metal detector knob on top which is connected to a pair of metal leaves hanging from the bottom of the connecting rod. When no charge is present, the metal leaves hang loosely downward, but when an object with a charge is brought near an electroscope, one of two things can happen. The first thing that can happen is when the charge is positive. Electrons in the metal of the electroscope are attracted to the charge and move upward of the leaves. This results in the leaves to have a temporary positive charge, and because like charges repel, the leaves separate. When the charge is removed, the electrons return to their original positions and leaves relax. Second thing that can happen is when the charge is negative, the electrons in the metal of the electroscope repel and move toward the leaves on the bottom. This causes the leaves to gain a temporary negative charge, and because like charges repel, the leaves again separate. Then, when the charge is removed, the electrons return to their original position and the leaves relax. The ways you can change an electroscope, there are many, but we are gonna say two. One is charging by induction. Rub an insulator to charge up. Bring it close to the top of the plate of the electroscope, but do not let it touch. This will induce the opposite charge on the plate of the electroscope, leaving a net charge on the gold leaf, which will rise. The second way is charging by contact. Rub an insulator to charge it up, then stroke it across the top of the plate of the electroscope. This will transfer charge from the insulator to the electroscope.
Hi, this is our electroscope, and this is the ball of aluminum, which is going to absorb the charge that we are going to put in there, a cork, which is act as a resistance, a flask, which is going to isolate the wire that is inside with the two aluminum leads, which are going to react to the charge that we are putting in. In this state, the electroscope has a neutral charge. Right now, I am going to charge it negatively with a balloon and with my hair. So, I'm going to start making friction with the balloon and my hair to charge the balloon negatively with convection. And right now, I'm charging the electroscope by induction. As you can see, as I approach the balloon to the electroscope, the leaves move upward, and if I touch it, I make ground. I ground the whole system. Here we can see the electroscope that is charged negatively with the balloon, and let's see if we can join those leaves together. Right now, I am going to charge the electroscope with a caballito because it's the only thing I have which is made about glass and I can't charge. And I will charge it, the whole electroscope, with a positive charge. And the system works, and the system is going to work that the positive charge of the glass is going to transfer that energy to the aluminum ball, and that charge is going to pass through the wire to the leaves, to the aluminum leaves that are above everything, that are downwards, sorry. Right now, I'm going to charge it by conduction. If I touch it, I'm charging it. I'm charging this way the caballito. Right now we can see that it's charged. And now I'm going to charge it. Oh, it discharged. Okay. Now it is charged positively by conduction with glass. That means that it has a positive charge. And now, as fast as I can, I'm going to put a negative charge in it with a balloon. And as you can see, the leaves will kind of join. They a little bit join. It's very, oh yeah, I think that you can see it in camera. I don't know, because it is very little, like the change. But yeah, that's how we charge, discharge, and know what is the charge of an object.
Now that we know this, we can conclude 3 specific things. The first one is that electroscopes could be very useful in order to analyze electrostatic charges and any ionizing radiation present in a body or also in the environment. Second is that the nature of the electrical charge is measurable using an electroscope. And the third one is that also with the help of an electroscope, we can easily compare the magnitudes of 2 different charges. Also, we can conclude that any electric charge brought near the conductor or in contact with it causes to the aluminum leaves to stand apart an angle, because according to Coulomb's law, the like electric charge either induced in or transferred to each leaf cause them to repel each other. And finally, we can also say that the angle formed by the leaves could determine not only the direction of the charge but also the magnitude. We still don't know how to calculate the charges with the angles, but we know that it is possible.